Okay, so now we are going to take a look at some examples involving the various kind of control structures that are present in the C programming language. You may notice in this particular example that I am showing over here that it consists of what looks like a very large C program, which is broken up in this way, right? There are some comments and a function, right? The function definition is out here, right? The name of the function is itself out here. We will get to what these details, right, things like void and so on over here in a later when we start talking about functions. But the reason that I have done this is just for convenience once again, to make it easier to sort of step through the different things that I want to indicate, right. So what I am going to do is run all the way down and go down to my main function, right, and as you would recall, main is just yet another function that is present in the C programming language. It is the function that gets called first when a program actually runs, right. So what I have done over here is I have got each of these statements one by one, which I can just uncomment, and what is going to happen over here is when I uncomment this, it is going to basically run the first demo. Okay, so let us go take a look at what that demo consists of. This is an example which talks about computing the roots of a quadratic equation. It is the one for which we saw a flow chart earlier, right. In this case, what I am going to assume is that I have three inputs, float a, b and c. In this case, I am actually going to read those values in one by one, right. There are a couple of interesting sort of things that you might want to note, right, which just make it a bit more convenient when you are writing your own programs. These are not parts of the language itself, these are just more sort of what are usually called idioms or different ways in that are, you know, different styles of writing code that might be useful in different contexts. One of them relates to the way that I am using printf followed by scanf, right. The details of printf and scanf we will look at later when we talk about I/O, but for now at a high level, all that you need to understand is printf displays something on the screen, scanf reads in something from the keyboard, okay. And you might also have seen from previous examples that if I put this character, the backslash followed by n in printf, what it will do is it will print what is there and then go down to the next line. So that backslash n is what is called a new line character. And what I have over here is I am intentionally skipping that new line, and the reason for that is so that whatever I read afterwards will remain on the same line as what I have printed so far, right. These are things that I would strongly encourage you to play around with. No amount of explanation from my side is going to really clarify it as much as just, you know, one example that you try out on your own, okay. Once you have tried it, you will see exactly what the difference is between the two options, and hopefully it should be clear at that point. So anyway, what this program does is it first, you know, reads in three values a, b and c. After that it computes this value disk is equal to b into b minus 4 into a into c, and it checks if this value is less than 0, right. So the if condition, the first condition that we had over there is essentially, right, the control flow that I wanted to demonstrate is out here. And what I am doing is if the condition fails, what I do is I print out a message saying this equation has complex solutions not handled and essentially return, okay. And in this case, I do not need to bother about that select signal. I have intentionally chosen something where, you know, I just print out both the roots, okay. So I do not really have a condition. So the only if condition that I have out here is like this. As you can see, the syntax is start with if, the condition to be checked must be within parentheses, right, the brackets. After that, open curly brackets, close curly brackets. That defines the block of code that is being executed, okay. Now the open curly brackets, close curly brackets is not compulsory, right. If instead of that I just had one statement over there, only that one statement would be part of what gets executed under the if, right. That can lead to problems later, we will look at that at some point, right. But in general, what you should, just for, you know, neatness of the code, it is always preferable that unless you really need to keep the code very brief, use the curly brackets, right. Once again, like I said, the choice of whether to have the curly brackets starting on the same line as the if or the next line is a matter of convention. I always prefer to have it on the same line so that the ending curly bracket lines up with the if and tells me where it ends. But apart from that, that's sort of, there are people who think the other way as well, right. But you will notice that the indentation is there, so that everything inside the if is definitely indented by at least 2 spaces in this case, preferably more in some cases, so that it becomes easier to quickly identify what part is inside the if and what is in some other part. What you will realize if you look at this code, right, if we try and understand what the code is expected to do, if this condition is satisfied, right, that is the discriminant is less than 0, I will just return after printing an error message. I will not even get to this part of the code. But if it is not, then I will basically get down over here, okay, and go through all of these things and print this stuff. So let us try running it, right. As you can see, it compiles and then goes down and asks what is the value of A. Let me try with just the value 1, then for B I am going to enter 2, and for C I will enter 1, and sure enough it prints out that the roots are -1 and -1, all good, right. So it has gone through the if, this condition was not satisfied, it fell through out here and went all the way down to print this message, the roots are, and so on, right. What happens if I run the same program again? Now I can run something like maybe 1, 2 and 3, and now instead I find that disk was less than 0. As a result, it prints out this message, the equation has complex solutions not handled, and gets out. It has just, in this case it has just returned from this particular program, right. That is one way of handling it. Strictly speaking, this is not ideal, because in some sense having a return somewhere in the middle of a function is not the greatest way of writing code, right. Ideally I should have like one point somewhere at the end of a function where I exit the function, and pretty much everything else should be handled using if else conditions, so that I always have one flow from the start of my function all the way down to the final return at the end. In some cases usually we end up taking shortcuts and return early or do something else of that sort. Depending on the way that you have your code, it may be acceptable, but think carefully before you write code of this sort, because having a return somewhere in the middle like this can actually make your code difficult to understand. Now the next demo is essentially the same thing, except that I have done something else over here. I have just used an else condition, right. So let me just activate that, and you will of course, you should notice that there is literally like no change in the functionality. And what happens when I run this is it once again asks me for this, and if I enter 1, 2 and 3 as before, it once again just says it has complex solutions and it is not handled, right. So here we are, essentially it is exactly the same code. The only difference is, rather than just having this fall through right after the if condition, I am actually explicitly putting it inside an else block, right. And the else, it also has the same kind of behavior, right. It has a starting curly bracket, ending curly bracket, or rather this is the ending curly bracket, and some code in between. Now one other important thing to observe over here is, notice this last statement on line 58 over here saying this should never be reached. This actually is something that can be precisely analyzed by a compiler, right. What this statement out here is actually something called dead code, right. And a compiler, if you have written all your ifs and elses properly, will actually be able to go through and identify that there is no condition under which I can actually reach this code, right. You do not need to put this in here, I have just put it in here as a demonstrator. In general you should never have to do that, but most compilers will actually be able to see that you either return at this point or at this point, and therefore there is no way that your code can actually reach here, which means that the compiler will actually just remove that code from your program and not even generate the machine code corresponding to it. Okay. That is one of the benefits of structured programming. It allows you to reason about programs. It allows you to identify the structure of a program and say this part is never going to happen, or this part will execute only under these conditions, right. And a lot of analysis on the properties of the program can be done using that kind of structure. So now let us look at the next example that I have taken over here. It is In this case I have actually got once again a loop. I have brought in the while keyword over here and I am using it. In fact, I am using it in a specific format where you can imagine what this is going to do. I have given a condition of 1. How does C interpret a value of 1 when it sees it? As true, which means I am basically saying while true, right? In other words, always, right? While true is equal to true, true is always true, right? That is what is called a tautological statement, right? So, the only reason I would do something like this is to create what is called an infinite loop, right? And infinite loops are usually not much fun. They usually mean that your program is hanging or something like that, but there are contexts in which it makes sense to put in an infinite loop, provided there is some way of breaking out of the loop, okay? And that is pretty much what we are going to make use of over here. The exact details of while we will get to later, but for now I am just using it. So, what I am going to do in this case is I will get into this loop where I print a message asking for a fruit code. I read in a fruit code. I check if the code that I have entered is equal to A. If so, I take one of my variables that I have declared and increment it, called apples. If it was equal to B, I will increment bananas. If it was M, I will increment mangoes. If the letter that you have entered is Q, then it basically prints out a message saying, okay, we are all done, you have so many apples, so many bananas and so many mangoes, and just prints that information out and returns. So, now you see how we get out of that infinite loop, right? As soon as I enter the letter Q, it is going to break out of this loop because return just ignores the while. It ignores everything and basically says, hey, I need to get out of this function, right? So, that part of it can be taken care of, but if not, if it is not A, B, M or Q, it is just going to print out a message saying I do not know how to handle that fruit and proceed. This is an example of the if else kind of condition that we looked at, right. So, we have if, else if and so on, finally followed by one final else which does not have an if after it, which means that any condition that did not match earlier is going to get hit here. As you can imagine, this is going to happen in sequence. I will first check if it is equal to A, then I will check if it is equal to B, then I will check if it is equal to M, then I will check if it is equal to Q. The important point is at no stage over here is the value of CH actually changing, so it does not really matter, but you can start constructing really strange code by actually going in there and changing the value of CH in the middle, because CH after all is just a variable that you have. What if I put CH equal to B after incrementing the number of apples? The next else if would actually get triggered, okay. So, let us run this and see what happens. So, it asks for a fruit code. I am going to enter A because I have an apple, then B for one banana, C it says it does not know how to handle that fruit, and now I am going to enter Q. And let us think about what we expect to happen at that point, right. So far I should see 1 apple, 1 banana and 0 mangoes as my result. I see 1 apple, 2 bananas even though I entered only 1, and 32,000 mangoes, right. This is good news for all of us mango lovers, but bad news for anyone trying to learn C programming, okay. The question is what happened? Why did I get this completely ridiculous result? If you look carefully, right, this should sort of tell you a little bit more about variables that we looked at earlier. I defined the variables, or rather I declared them, I never initialized them, I did not give them initial values, so I do not know where to start from. And C does not guarantee that a variable that is declared in this way will have the value 0. Okay. How do we fix that? Probably the easiest way is just combine the declaration and initialization. Oops, make sure that you have got the syntax correct, of course, and mango is equal to 0. You can observe that what I am using over here is the comma operator, right. Remember the comma operator from operators, and there is usually not a particularly good reason for using it. In this case it turns out to be a nice thing to have, right. It allows us to combine all the declarations and initializations into a single line of code. There are places like this where writing it like this can actually be helpful, right, because when you initialize along with declaring it, it makes it very clear what exactly you are trying to do. And having multiple things initialized on the same line is also fine, provided that they are closely enough related, right, so that it becomes easy for someone to look at it and say, hey, yeah, this is just a bunch of different types of fruit, you are initializing them all together. That is easy to understand, there is nothing confusing here. Now what happens when I run this, right? Hopefully things are better now. I have A, B, C. Once again, now I should have 1, 1 and 0. And yes, I have 1 apple, 1 banana and 0 mangoes. Okay. So remember the initialization, that's something important that needs to happen out here. So this was an example to show what happens if we just have else if conditions, right? We will also look at it later in a slightly different context, but it's just typical standard, the most common form of usage of the if else statements in C. Now let us look at another example, and this is to show you the importance of indentation, right, and why proper indentation can be very important to actually understanding what a program is supposed to do, right. This is clearly a made up example, but on the other hand it is quite easy for you to encounter something like this in practice, right. What I have is I have a function where I have declared a variable a is equal to 1 and I check if a is less than 2, printf the first statement, printf the second statement, and that is the end of the function. Okay. Let me run this and see what happens. It prints out sure enough the first statement and the second statement. Okay. That is more or less what we expected. Now what happens if I change a is equal to 3? And here is the catch, right. Especially someone who is used to something like Python programming would normally look at this and say, okay, 3 is not less than 2. So I would expect that it should basically skip the statements and not print anything. Okay. But what happens over here is it does print out the second statement anyway, right. And the answer of course is obvious, right. I was sort of a big build up to something very small. The if condition was not satisfied, which means that the statement immediately after it was not executed, only one statement, right. In the previous cases, as you will see, I had enclosed the statement to be executed within curly brackets. Over here I do not have curly brackets, so it takes the next statement, which in this case happens to be printf, and says, okay, I do not need to execute this statement. But the one after that does get executed even though it is indented and looks as though it is part of the if condition, right. So this can be potentially very misleading, right. There are a couple of different ways to handle this. One of them of course is probably use curly brackets, right, do not leave them out. The second is, the lesson to learn here is that your indentation should be correct, not that do not indent, right. You could also have probably solved this problem by not indenting anything and saying that, hey, I need to actually read this code carefully to understand what is going on, right. It just becomes impossible to read after a while. So in this case, the correct way to do it would be use the right amount of indentation. The other safe way would be use curly brackets, be explicit about it, right, be very clear about where exactly what is the statement that is going to get executed after the if. Now the interesting thing about Replit is, if you actually just save by hitting Ctrl S, right, you will notice that this line automatically shifted to the left. And the reason for that is Replit by default runs a formatter on your code, right. A formatter is essentially something which follows certain standardized rules of formatting and tries to clean up your code so that your indentation etc. looks good. Okay. I would actually strongly suggest that you make use of that, right. Make use of the fact that Replit has the ability to clean up your code, but do not just fall into the trap of assuming that your editor is going to take care of things for you, but try and use editors and tools that will actually help you with your coding, right. So it is not that this is a bad thing, this is definitely a good thing. The kinds of things that an editor can do in order to help you with finding out where there are bugs in your program are very useful, especially if you are trying to write any non-trivial kind of programs, and also when you are trying to debug programs. So this was a relatively minor but useful thing to keep in mind. So something to remember when you are writing the if statement in C.